All right, good day, or good night, or day, depending on where you are. All right, so what we're going to do today is we're going to go through this BMED past paper question right here. This was question 4 on the 2018 paper. All right, so it gives us this question here. It says that figure 4 shows a right pentagonal prism 100 millimeters long, which has a 35 millimeter hole through it. So it has a 35 millimeter hole through it, which is this hole right here, going all the way through it. All right. So that would be like this hole right here. So this is like a sharpener, right? Like a sharpener, and then you have the hole going right through the sharpener. So it's like that. So the hole is going right through our pentagonal prism. All right, so it gives us the height for 100. It says that each side is 35, and this circle has a diameter of 35. Now what we are supposed to do here is we are to draw this in as it is in orthographic, and we are also supposed to construct the development. All right, we're going to show the curves and show the folding lines for a total of 20 marks for this question. So to start off this question, we can start off with either the front view here or the plan view, but I'll start with the plan. Well, we actually need to start with the plan view. We need to draw the pentagon first. So for the pentagon, it says that all the sides are 35. So if it's the sides, let's see which one we'll use here. So for this, we'll use polygon. So let's use polygon. So if you're given the side, let me see which one we use here. It's either circumscribed or inscribed. So the number of sides is 5 because it's a pentagon. So for this one, we could also use edge. Yeah, so we could use edge, and we could click here, and then we're supposed to draw the here now we would draw the length of the side here. So the side here would be 35 millimeters. So it's at 35. All right. Let me see if we could also, other than doing that 5 sides, there should be an option for us to also, other than using edge, there should be a inscribed or circumscribed option, but I'm not seeing that option. Probably 24 is different. Yeah, because I guess edge makes sense, because with the edge you can draw it, so it doesn't matter. All right, so this is our pentagon right here. So we need to rotate this a bit. So let me just use the rotate command here, and I will rotate it because we want it to be standing up like that. So I want it to be like this. But once you have ortho turned on and you use the rotate command, it will rotate and give you your pentagon like this. So that's our pentagon, that's the plan view. So we will change this, but instead of changing that, I'm going to change this one, but then I'm going to create a construction layer as well. Normally I would construct my layers before the drawing, but I wanted to show you the entire process of this. So for this now, we're going to make the construction line, well, that's the 0 layer. I don't need to change that. What I need to do is to create a different layer on the create option there, and let's call this construction. So that's our construction line, and then we are going to make this gray color. So let's make our construction line gray here, so like this. So that is our construction line. Nice. Now once we have that, we have the plan view, so we can do the rest of the drawings now. So each side of our pentagon here is 35. So what other information do we have here? So it says that the height of this is 100, and then we have a circle here with a diameter of 35. All right, and this circle is going right through our prism here. So how do we go about drawing this now? So to draw this, what we're going to do is we're going to go into the construction layer that we just completed. Let me just change this layer to a white layer here, and then we can go into the construction layer. So now what I'm going to do is this. I'm going to bring down one line from this point here. Actually, let me just go by layer here. By layer. So I'm going to bring down one line from the center here. So I'll bring this line down like that. All right, and then I'm going to click on this line here, bring this down as well. The distances doesn't matter right now. And instead of bringing down the other lines, I could just copy one line instead of drawing more lines. So I could just simply copy this line here. So I could copy this and copy this also, and I could also copy that there. All right, so there we go. So now we can draw our front view. So to draw the front view, what we'll do is we'll go back to our outline layer or zero layer. We're just going to choose a place below our plan view here to draw our front view. So let's say we start our front view here. Good. Now it says that the height is 100. So this line here, I'll just bring this down by 100. I could have also offset this line by 100. This would still work the same way. So I'm going to come across here and bring this up to here. Now, for this, what are we seeing here? So what we're going to be seeing here in our front view, we're seeing this edge, we're seeing this edge, and this edge. We're not seeing this edge over here. So we'll have to represent that with broken lines. We already drew this edge over here to the left and the edge over here to the right. So we need to now draw this line representing this edge and this line representing this edge right here. All right, so to draw that now, this is what we're going to do. We are going to select a line here. We're going to draw a line from here to there. You could also just copy this line, but I'll just draw that line there. Now, the next important information that we have here is this circle here. It says that this circle is 35 millimeters and it's directly in the middle of our prism. So for us to draw that now, this is what we need to do. If this entire distance is 100, then the middle will be 50. So we can offset this line here by 50 just to get the center of our circle. So the center of our circle would be right here. All right. We didn't have to do that either. I could just come here, move my mouse down and type 50 and it would give me the center. So that's the next way you could have gone about doing it also. So my center is here now. So I'm going to draw this circle. The diameter of the circle is 35, which means that the radius is going to be 17.5. So about there. Alright, so it will go to about that point. Nice. So once we have that now, this is what we can do. We can then delete this line. We no longer need it. We just use it to draw a circle. So there we have that. So this shows the completed front view. And well, this side around here, this edge is there that we're not seeing. So it comes to here and then it comes down here also. So we could represent that with a broken line. So we could do this like that and like that to show that there's this line around the front we're not seeing, but it's there, so we represent it in broken line. So that would complete the plan view, and this is the front view. All right, good. So now the next thing that we'll have here is this. It says that we're supposed to complete the development. So we haven't done the development. We just did the plan view and the front view, but we need the plan view and the front view for the development. So that's why we did that. So to do the development now, the development is what this would look like if you were to open it out. If you were to open out the prism. So it would look like this. So this is what we need to do. So let me go back to the construction layer. So you're going to draw a construction line from here. Bring this across. Actually, let me go by layer here. Yeah. So we're going to bring across a construction line. The length right now doesn't matter. And bring across the next one from this edge here also. We'll also bring across one from the top of the circle here, like that. We could copy, and then we'll just copy this one, and we'll copy to the middle of the circle, and then to the base of the circle down here. So we have that. All right, nice. So once we have that now, the next thing that we're supposed to do is this. We're going to choose a place to start our development. Doesn't matter where. I'll go with outline for this instead of a construction line. So let's say that we choose to start our development right here. Good. So we're going to offset this. Now, what are the offset distances going to be? So the development is going to be, the length of our development here is going to be equal to the perimeter of our pentagon. All right, so it's going to be equal to the perimeter for a pentagon. Now each side of this pentagon is 35. So what I can do, I don't even need to do any math. I can just offset by 35, and I can do this 4 times or 5 times. So that's 1, 2. So this represents 2 sides. 1 side, 2 side, 3 sides, 1, 2, 3, 4 sides, and then the last one 5 sides. So this here would be equal to the development distance. All right, this distance here from here to this point here, and from here to over here, that would be equal to our development distance. So what do we do with this information now? This is what we'll do with this information. These lines here, these lines, all of these lines here are going to be in broken lines, and I'm going to explain why. So these lines are going to be in broken lines because those edges will be folded. All right, so the edges will be folded, and because they're going to be folded, what broken lines in surface development represent is all the places that we'll fold, or all the creases. So we'll fold here, 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 and here, but we won't fold this edge or that edge because those edges will come back and meet each other. All right, so the circle is in the middle. So in this case, the circle will be somewhere in here. All right, so the circle will be somewhere in here. No, actually the circle won't be in there. Well, one circle will be in here, but the circle will also be on this side and this side as well. Now why is that? The circle goes all the way through our pentagon, so it goes through to here and it goes through to up here as well. All right, so we're seeing the circle here, but it also goes through here and goes through here. So if we're to open this out, open the development out, we will see this part of the circle here and part of it here represented as ellipses, or parts of an ellipse. All right, so for the circle that will be in the middle here, so what we can do is this: we'll copy the circle. So we'll copy this circle from the center here and bring it to, actually let me copy it from the edge. So I'll copy the circle from this edge here, any one of the edges or quadrants, and bring it to right at this point here. All right, now how do I know that this is where the circle will be? Look at it. We have 1, 2, 3, 4, 5 sides that are a pentagon. The circle is on this one right here, the one in the middle, because if we were to open this out, we'll have 2 sides to the left, so 1, 2, then this one in the middle, and then 2 sides to the right. So here we have 2 sides to the left, 1, 2, the one in the middle, which is the one that the circle will be on, and then we have 2 more to the right over here. Now, the next thing that we need to do here is this. We are going to need to draw the circles over on this line and this line, and as I said, they'll be represented as parts of an ellipse. So how do we go about doing that? So let me show you. So what we'll do is to draw a line from here, just a vertical line like that, and then draw a next vertical line like that. Why did we do that? This is why we did that. We can measure this distance here, this distance from here to here. Let me just, for my units, let me just turn off decimals. You could set it to 1 decimal please for accuracy, but for the sake of simplicity, I'll turn off decimals. So I'll measure the distance from here to here. So it says that that distance is 22. All right, so this is what I'm going to do with that information, being that the distance is 22. So I am going to offset. Am I going to offset? Yes. So this edge right here is the same as this edge right here, which means that this line here represents this edge here. So from here to here is 22, so I'm going to offset by 22. So I'm going to offset like that. All right, and then I am going to put this in a construction layer. Now, so what happens here now is this. Well, if we're to look at this, we're going to see the circle going from here and it goes down to here, but it's going to look like a part of an ellipse. So to draw that, just turn on the 0 layer, and we can use the ellipse command here, and it says specify center. So this is the center. Specify first endpoint is there, and then the next endpoint is there. So then now we'll trim this. So tr enter, and we trim this, we trim this, we trim this piece, and we trim this piece. Now this is going to be the same over here on this side. So instead, we could draw it over here on this side again, but we could also mirror it. But for the sake of simplicity, I think I'll just draw it back because I'm explaining. So again, the distance from here to here is 22 because we had measured and we got this, that from here to here is 22. Good. So we'll do the same thing here. So offset by 22 and bring this across like that. And let's put this in the construction layer. Alright, then the next thing we're going to do is this. We're going to turn on ellipses. The center of our ellipse is going to be right over here. Yeah. And then now this is going to be 1 point, and then no, that's not the center. The center of my ellipse is actually right here, and this is 1 point, and this is the next point. So this here, and then that's 1 point, and this is my next point. Wait, where did I click as my center? The center is along this line, so it is right here. Good. It says, so if that's 1 point, why is my... Alright, let me see something here. I can mirror this, but I don't want to mirror this. I want to draw this. So if this is the center of my ellipse, so the center of my ellipse is over here. So that's the center of my ellipse. So one axis is over here. Yeah, and then the next axis is right there. Good. And then we can trim this. So if I trim this, trim this, trim this, and trim that right here, what we get here is this. We have this ellipse here. Good. And then we have this next ellipse over here. Alright. And that then now gives us our surface development, except for one thing. We need the lid. So for the lid, we already have a pentagon here. It's a pentagonal lid and a pentagonal base. So all we have to do is to just copy this pentagon and bring it to this point. It doesn't matter, just any one of these points. I could have put it here or here, anyone, it doesn't matter. No, it has a base as well. So because it has a base, I am going to mirror this from, I'm going to mirror it along the center line. So like this, like that. Erase source object. No, we want to keep the source object. So then we have this. Now remember, for surface development, broken lines represent the spaces that are going to be folded. All right, represents the spaces that are going to be folded. So now this here, this part here is going to be folded because it is the lid, and also this part for the base will be folded. So let me show you how we go about doing that. But before that, let me just draw this line to close off this space here, and also to close off here. Again, this is symmetrical, so you could literally just do half and mirror it, but I'm just doing the entire thing so I can explain the entire thing. Alright, so I have that. Now here, for this to represent this as a broken line, we're going to have to explode our pentagon because we just want that one line to be a broken line. So we're going to explode, use the explode command. So now we can just change this line to a broken line. Alright, and we can then explode this one as well. Probably should have exploded it before I mirrored it. So yeah, explode it before you mirror it, and that would save you some time. And for this one, I'll do this. Or you could also use the match property command. Alright, so here we have it now. So based on what the question asks us to do, this question here, it says it's a right pentagonal prism. The hole goes right through it, so the hole goes all the way through, which is why we have the ellipses. So it says construct the surface development. We did that. Show all curves. We did show all the curves. We showed our ellipse, which is here, this next ellipse, which is here, and we also have our circle here, and this next circle right here. All right. And then now the last part of the question said that we should show all folding lines, and here you can see we have all our lines that will be folded, this and that as well. Now visualize this. It's a pentagon, so if you were to fold all the sides, so you fold it, so this edge here would line up with this edge, and you're folding it around, so this edge would line up with this edge here lines up with that edge, and then this edge lines up with this edge here. So when this edge comes around, it's going to meet this edge, and this edge would meet up right here. So when those come together, if you're looking from here, these two ellipses, this half ellipse and this half ellipse, they're going to come together, and you looking from here, it's going to look like a circle. All right, so it's going to look like a circle going all the way through, which is why we have this circle here and the ellipse on the left and the ellipse on the right. Good. And that's how you would go about answering that question. So again, this question was number 4 from the 2018 paper. All right, 20 marks question, so 20 marks for that. Good. All right, so I do hope you found this video helpful. I try to go live every Monday at about 6 Central to do some BMED questions. Yeah, so that is all for today, and we will continue next time. All right, so thanks for watching and have yourselves a fantastic day.